I'm going to do 2-3 algebra problem and then calculus problem. We're not going to spend that much time because this is not a math lecture. This is physics lecture, but you know, physics and math goes hand in hand. So we have to have a good understanding in math. So let's see what math we can solve. What math we need to understand physics. Alright, so the first one, I want to tell you, I want to see whether we have a good understanding of graph. So if y is x, then how the graph look like? This is how the graph look like. It's 45 degree, and the slope is positive. What about y is negative x? Then graphs is the other way around, and slope is less than 0, which is negative. This case, the slope is 0, y is maybe 2, I guess. The slope is 0 in this case. And then this one, x is maybe 3, 1, 2, 3, so x is maybe 3, but the important thing is the slope here is not defined. One more graph I want you to understand, which is y is x squared. We're going to use this one more than twice. So y is x squared is simply, that's how it's going to look like. Y is x squared. If you plot the point, you will see that's how y is x squared, y equal to x squared look like. And likewise, y equal to negative x squared look like upside down parabola. Alright, so this is, as I said, I'm going to keep it simple. I'm not going to discuss any other math that's not we're going to see in the physics lecture. So of course you need to know more, but this is this understanding or having idea of this, how this look like, it's very necessary to moving forward. And I'm going to do one more algebra problem. Let's see. Let's find the equation of line. Find equation of line. Point 2 minus 1. This is parallel. Is it spelling correct? Or let's not worry about spelling. Which is parallel to 2x minus 3y equal to 5, and perpendicular to, what can we write? We're going to write the same thing? Let's write the same thing. 2x minus 3y equal to 5. Alright. So let's do a color coding. Let's highlight it by yellow and this highlighted by blue. Alright. So let's do the top one, parallel one. Let's see. You can write step 1, and then the equation is 2x plus 3y equal to 5y. Alright, so what are we going to do? We're going to isolate y. To isolate y, we're going to send this guy to the other side. Let's do that. 3y equal to 5 Well, let's write minus 2x plus 5. Why minus 2x? This is positive 2x, so when we send it to the other side, this is right hand side, this is left hand side. Okay, when we send something from right hand side to left hand side, the sign changes. So we have 3y here, right? So let's isolate y, that's our goal. Y is simply, so this 3 now right here. So what is our, we can rewrite it 2 over 3 x plus 5 over 3. Which part we care about? We care about only this part. We care about this part because this is slope. So now they are saying that parallel. So now we can write m is minus 2 over 3 and m parallel. Parallel we can write like this. Parallel, two lines never touches each other. That's what parallel is. And this is very simple. You're going to keep it like this. Nothing changes. All right. So the slope and the parallel slope, they are same, as you see that. Now how are we going to make it a line? We're going to use the line intercept formula, which is y equal m x minus x1 plus y1. All right. Now here we can call it x1 and we can call it y1. Right. This is x1 and this is y1. So what is our, so let's plug it in, then we'll be able to get the line. M is 2 over 3, negative 2 over 3, and x1 is simply 2, y1 is negative 1. Right, so y is 2 over 3. What can we do? We're going to distribute this. So when we distribute that, this is 2 over 3x, and then plus, I guess, 4 over 3, and then here you have plus 1. So y is 2 over 3, there is a negative x, and then here you have a LCD, here you have a 4 plus 3, 7. So this is your line parallel to this point. So let's do the other one. Let's do the other one using the color coding, maybe blue this time, because I box it using blue color. So 2x minus 3y equal to 5. So we're going to do the same thing. We're going to keep the 3y this side. This I use the plus, so let's make it plus. I think I made a mistake, but anyway, it doesn't matter as long as we understand that. So 3y equal to 5 minus 2x. So we can write 2x minus 5. And keep making mistake. You have to put minus over here because you're sending this guy to the other side. Now y is equal to, you should get the same thing. Y is equal to negative 2 over 3x, and this is actually plus 5 over 3. All right. So now, what is your slope? The slope is negative 2 over 3, and then this time it is perpendicular. So M perpendicular is 3 over 2 and the negative become positive. That's how you make perpendicular. Alright, so now we're going to do the now same thing. Y is M x minus x1 plus y1. Alright, so what is our M? M is 3 over 2. Notice this is, in this case, this was parallel, so nothing changed. Since this is perpendicular, for example, if you want to make, for example, this is like, 5 over 7. How are you going to make it perpendicular? You're going to make it perpendicular by simply, they flip, so 7 over 5, and since this is positive, you're going to put negative. That's how you make something perpendicular. But parallel is easy, straightforward. You don't do anything. You keep it as it is. So the slope is 3 over 2, and x minus x1 is here x1 is 2 plus y1 is minus 1. All right. Now here I made a mistake. Here plus minus minus, it should be minus. God, we are making so many mistakes today. So this one would be then 3 over 4 minus 3, then it's going to be 1 over 3. All right. I'm glad that I saw that. Now let's distribute that. So 3 over 2 x minus 6 over 2 plus minus 1. Let's not make mistake anymore. 2 goes to 6 3 times, so it's going to be 3 over 2 x minus 3 minus 1 is minus 4. So notice here we have negative, here we have positive. So let's see how they intersect each other. So let's draw this one. Let's write y equal to minus 2 over 3x plus 1 over 3 plus 1 over 3, and this one is y is 2 over 3x minus 4. 1 over 3 we can write what? 0.33, something like that. 0.33. Okay. So let's grab that. So this is our rise, our run, and this is our y-intercept. Okay. So let's go to y-intercept. Y-intercept is 0.33. So say this is 1 and here is 0.33. So now you rise 2 unit up, but there is negative, so you fall 2 unit. So you fall 1 unit, 2 unit, and you run 3 unit. 1, 2, 3. All right. So now you connect this one and this one, and it's going to be look like that. All right, more or less. And this is this one. All right. Now the blue one. Let's see. You go to negative 4. That's your y-intercept. So 1, negative 1, negative 2, negative 3, negative 4, maybe here. And then you go 2 unit up, 1 unit, 2 unit, and then you run 3 unit. 1, 2, 3 unit. Okay. So this is your intersection. So these two graph, these two function, they intersect each other right here. What is that point? Maybe this is 1, 2, 2, comma, negative 1, negative 2. Okay, that's its intersection. Okay, so that's the algebra. Now we're going to do a little bit of calculus before we move on to the physics. The calculus, so we're just going to simply talk about differential calculus. I'm gonna discuss most easiest examples of differential calculus and integral calculus. So what is differential calculus we're going to discuss about? We're going to discuss about power rule, and we also going to discuss product rule, and then quotient rule, and chain rule. Okay. And then we're going to do some example from integral calculus, but to understand that we need to understand a limit. What is limit? Let's see. Let's write a problem. Y is equal to maybe x square, right? Let's take the let's understand that. Let's grab that first. All right. So that's how it looks like, right? But we're not going to worry about the left side because, you know, in physics we're not going to deal with the negative number. So we're going to deal with only the positive side. Okay? So in algebra, when we had to take the slope of a line, what do we do? What do we usually do? If y is x, then there is a line like this, and if this is x1 and this is x2, then you have, there is your y1 and there is your y2. So what you basically do, slope of a line is y2 minus y1, x2 minus x1. All right. So now this is something different, but not too much. The idea comes from the algebra. But here is a problem. Algebra we deal with the straight line, but we have to use the calculus here because this is not a straight line. This is a curve. We cannot use this formula to find the slope of a curve. So what we do, we use the tool we call calculus. So let's say this is our x, and this is our, not x2, x plus h. What is x plus h? X plus h is a little bigger than x. For example, if x is 2, x plus h is 2.0005, even smaller. In this case, if x1 is 4, x2 is maybe 6. In this case, if x is 2, x plus h is a little bigger than 2, maybe this big. All right. So then, what is this one then? This one is f of x, and this one is f of x plus h, right? So what do you do if this approaches to 0, if this change approaches to 0? What that means? That means if this change, the 2 and 2 point something is becoming, so what is the change between, what is the difference between this number and this number? Very close to 0 difference. That means if h approaches to 0, then there is no difference between this and this. That's what we write like that. We use the very fancy notation to express that. Limit as h goes to 0, we write, here we wrote y2, here we're going to write f of x plus h minus f of x over here we wrote x, here we wrote x2, here we're going to write x plus h. Here we're going to write x plus h minus x. So now what are you going to do? X cancel, and limit as h goes to 0, f of x plus h minus f of x over h. All right. So this is the definition. This is the definition of a derivative. What is the derivative of this guy? We can simply use the power rule to take the derivative of this. We can write y prime equal to 2x. But let's use the limit definition to calculate the derivative of this function. All right. So let's do it here. I think we have enough space over here. Let's do it here. So what is the problem side? Limit as h goes to 0, f of x plus h minus f of x over h. So now what can we do? Let's see, x plus h squared minus x squared, I guess. Limit as h goes to 0. Now we can use a plus b squared formula, which is h squared plus 2xh plus h squared minus x squared. No, this is x squared plus 2xh plus h squared minus x squared over h. Right. So the good thing is they get cancelled. So limit as h goes to 0. What is the common GCF? H. So this is 2x plus h over h, and h is cancelled. What is that then? Limit as h goes to 0, 2x plus h. Now h approaches to 0, then the y prime is 2x. All right. So that's what we actually got. Y prime is 2x. That's the power rule. But we use the limit definition to get the derivative of this function. I hope you understand. Let's do one example from power rule, and then product rule, quotient rule, and chain rule, and then we will discuss all those beautiful laws of physics step by step. Then you will understand what's going on inside Newtonian mechanics. Anyway, power rule, you're going to use this formula. D over dx is xn. All right. So what is x? X is a variable and n is an exponent, right? Of course, we're going to do an example, then you will understand that. So, but simply let's write what that do. This means this is a verb that says take the derivative of this guy inside guy. This just means take the derivative. My handwriting is becoming ugly, but anyway, I hope you can read it. Take the derivative. This means take the derivative of this guy. Instead of write d over dx, if I write take the derivative of this, then it would look like an English literature. So that's why we have to use the notation, math notation, to make it simple, because we don't have enough space to write all the big line. So that's what that means. So what is this? This is, you bring down the n, all right? So x n minus 1, all right? So let's find a simplest example to use the power rule. Maybe you can write, what can we write? Y is 3 x squared. All right. Now let's make the color of 2 green. All right. So what we do? We did y prime. Now this n gonna come over here. So this 2, the green guy gonna come in front. So we're gonna bring down the green guy, and then we write the coefficient, and then we write x, and then the green guy, then the blue guy here minus 1. So we're gonna have this guy, the green guy minus 1. Okay. So now it's simple. 6x1. All right, that's the power rule. I'm not going to do more example because I think this is pretty simple. So let's do the product rule. Product rule is basically say that derivative of first f of x, derivative of first times second plus derivative of second times first, right? So let's write an example. This is product rule. All right. So let's write an example. What example we can write? Maybe 3x minus 2x squared, and then 5 plus 4x. All right. Now, what does that mean? That means this guy is f of x, right? And this guy is g of x. Or you don't even have to use this fancy notation. You can call this guy the first and this guy the second, all right? So the chant, we're going to use the derivative of first. So this is the derivative notation, derivative of first times second, this is the second, plus derivative of second times first. All right. So we can say that we don't need to use this fancy notation. I'm going to cross it out as long as we get our math correct. So derivative of first times second plus derivative of second times first. So let's take the derivative. What is the derivative of first? Derivative of first is what is the derivative of 3x? 3 plus minus what is the derivative of 2x squared? We can use the power rule. 2 to the 4, 4x. Right? Times second, 5 plus 4x plus derivative of second. What is the derivative of second? What is the derivative of constant? Any derivative of 5 is 0. Derivative of any constant is 0. Derivative of 100 is 0. If you want a more dramatic, you put 5 million. How many is 0 after million? I guess 6. 1, 2, 3, 4, 5, 6. What is the derivative of 5 million? 0. So that means derivative of any constant is 0. So what is the then derivative of this guy, whole guy second? Is simply 4. All right. How 4? Let's show you 4x, right? What is the n over here? N is 1, all right? So you bring down the 1, 4 times 1, right? X, 1 minus 1. So 4x 0. So what is x raised to 0? 1. This is 4, right? So that's how we get 4, all right? Maybe you already know. So that's what we get. And you can do the cross multiplication, but I'm not going to do the algebra here. My intention is to start physics as soon as possible. We're going to do 2 more differential calculus example, quotient rule and chain rule, and then we're going to do one integration, then we'll move to physics. All right. So quotient rule. The quotient rule is we can let's write example of quotient rule. 5x minus 2x squared plus 1, all right. The formula for quotient rule is kind of fancy. The derivative of top times bottom minus derivative of bottom times top and then bottom square. All right. Now we're not going to call we can call this guy f of x, but we can call this guy top, and we can call this guy bottom. All right. How that help us? That help us to memorize that. So now instead of calling f prime of x, we can call derivative of top times bottom minus derivative of bottom times top bottom square. All right. So it's up to you. You can use this formula, or you can use the formula book use. The formula that book use, that's kind of looks difficult, but it's basically same. It is same, not basically. Sorry to confuse you. Anyway, the derivative of top is, what is the derivative of 5x? Simply 5. What is the derivative of constant? We already said that derivative of constant is 0. All right, times bottom. What is bottom? X squared plus 1 minus derivative of bottom, which is just 2x. What is the derivative of 1? 1 is 0. And then the top, 5x minus 2, and then the bottom square, x squared plus 1 square. All right, so I'm not going to do the algebra, but here's what we had. 5x squared plus 5 minus 10x squared minus plus 2 plus 2x over x squared plus 1 squared. All right. So I'm not gonna bother solving that, doing the algebra. That's not my intention here. I'm just going over the necessary calculus that we need to know to understand the physics. Last not the least, differential problem. We're going to use the chain rule, right? So chain rule is even easier than the quotient rule. The formula that books use for chain rule is like this: d over dx, which is a bar. Take the derivative of maybe f of gx. All right. So which is, you can write the way book write, f of g of x and then g prime of x. All right. So let's put an example. f of x equal to 3x minus 2x squared is to 3. All right. So this one is inside, so this one is, we can call g of x. All right. And this one is, whatever outside is we can call f of x. All right. So let's see. There is another way to understand. Take the derivative of outside, then you can think as if this is a bluff. Write the bluff and take the derivative of inside. So let's write what I mean. This is the derivative of outside. What is the derivative of outside? N is 3, so n becomes in the front 3, and you just don't do anything. You just copy that. 3x minus 2x squared. 3 minus 1, and now you take the derivative of inside. You can write d over dx 3x minus 2x squared, right? D over dx means you have to take the derivative of this guy, g of x, which is inside. All right, so now 3x minus 2x squared, 3 minus 1 is 2. Now you take the derivative of this one, which is 3 minus 4x. All right, so that's it. That's how we use the chain rule to take the derivative. Now let's do one integral problem and then move on to the physics. All right, so what integral problem we're going to do? Integration. So let's do the simple one, x and dx. X and dx, we have only 5 minutes in this, so we have to finish quickly. So what is x to the n? X to the n is x n plus 1, n plus 1 plus c1, and n cannot be -1, because if n is -1, then you have 0 downstairs, which is undefined. So let's see, let's find an example. 3x4 minus 5x squared plus x dx. All right, so use this formula to integrate that. This is a sign of integration, okay? So let's see. So what are we going to do? We're going to use this formula. So we're going to write 3x4, which is 5 over 5, minus 5x 3 over 3, then plus x squared over 2 plus c1. All right, so simply here, why I write 5? I write 5 because n is 4, n plus 1 is 5. Now why I write 5 here? Whatever you hear, you divide by that. That's the same thing I do it here. All right, so that's the integration. Why c1? C1 is because we do not have the limit here. If we have limit here, then we don't have to end up with c1. So let's put some limit here. Let's put x is 0 to 1. All right, then we don't have to have c1. Instead of c1, we can write 0 to 1. Let's see what happens. Now let's put 1 everywhere you see x. So 3 over 5 minus 5 over 3 plus 1 over 2, and then if you put 0, everything becomes 0, so you don't care about that. So what is the LCD? LCD is 5, 3, 2, you have 30. So 5 goes to 30, 6, 18, minus 3 goes to 10, 50, and 2 goes to 30, 15 times plus 15, right? So 15 and 18, 33, okay, so minus 17 over 30, right? So that would be the area under the curve. So that's all we have for math. Now we're gonna do the physics. I hope you understand the last. I hope I wasn't rushing. I hope you understand that. All right. So now we're gonna do physics.